prepare for your exam. Okay. Okay. Any questions?
Prof.
Yeah.
Meaning that if you use different samples, that can be a factors, isn't it?
Yes, definitely. Anything that is not constant should be a factor.
Yeah.
So if you are not interested in it being a factor, then you have to make it constant.
All right, thank you.
Okay. 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 Any other questions? Okay. Okay. Good. Okay. So the next one will be. Okay. Supposed to go. We still have time. Syafiqah Farhan. Okay. Okay. Sila Farhan. Okay.
Boleh nampak ke slide?
Boleh. Saya boleh nampak.
Okay. Okay. Assalamualaikum and a very good morning to Prof and fellow friends. Today I would like to present on my research project on the studies of polytetrafluoroethylene exposure time and concentration on hydrophobic coating of spray-dried non-extract. Let's proceed to problem statement in this project. Thermoplastic behavior of low molecular weight sugar in noni juice composition lead to stickiness in spray drying process can be a factor that has limited the use of spray drying of noni juice. Stickiness of the sugar is due to low glass transition temperature. Stickiness problem is lead to reduce the free-flowing property and product recovery in spray drying process. Process-based and material science-based approach are among of the methods for reducing stickiness. However, there is some limitation of this approach. Hence, a novel approach needs to be studied to reduce the stickiness in the spray drying by modifying the surface properties of the drying chamber and cyclone of the spray dryer. So the objectives of this research are to determine the effect of exposure time and concentration of PTFE, which is polytetrafluoroethylene, on the spray dried model solution using RSM, response surface methodology. Second one is to determine the effect of exposure time and concentration of PTFE on the powdered noni extract using RSM. And last one, to validate the best surface treatment of the highest yield of powdered noni extract. For experimental flowchart, the first step is the preparation of sucrose maltodextrin model solution, and then preparation of PTFE coated plate and plasma treated PTFE plate. Preliminary test on surface treatment of plates is conducted using model solution. Next, preparation and extraction of noni juice. Operational parameter optimization is conducted with respect to PTFE coated plate and plasma treated PTFE plate on spray dried noni juice. After that, analysis of response, which are contact angle, flood adhesion weight, hygroscopicity and moisture content, and analysis on structure and composition of the sample plates via SEM, FTIR and SPS are conducted. And last one, selection and verification of the best treatment to obtain the highest yield of spray dried noni juice with minimum stickiness properties. Move on to the statistical test. Two-way ANOVA is conducted followed by mean comparison using the multiple means comparison test, MMCT, which is Duncan, And the significant difference is based on the 95% confidence level. For design of experiment, this method involved in this study is central composites rotatable design (CCRD), defined as per statistical software, is applied to design CCRD and analysis of experimental data in RSM. And the experiment is designed to determine the optimum condition for the factors, which are PTFE concentration and exposure time on the response, which are contact angle, flood adhesion rate, hygroscopicity, and moisture content. The range is selected based on previous study to determine the optimum combination of factors. There is two levels which are low and high. For PTFE concentration, 4% at low level and high level is at 20%. And for exposure time, the range is between 6 minutes to 30 minutes. Based on the CCRD, 13 runs of experiments are conducted, including 5 replication at center point. As we can see in here in the table, 5 reps at center point for run number 1, 6, 9, 10, and 12. With the PTFE concentration and exposure time is 12% and 18 minutes respectively. Here, this is my reference for this study. I think that's all from me. Thank you.
Okay, thank you, Farhan. Okay, so now I open it for any questions that you may have. Okay, no questions? Any questions? Everything is clear? Okay, so if there are no questions, then okay, thank you, Farhan.
Okay.
So I will then share with you the quiz. Okay, there are 2 questions here. So you may start now. You have 10 minutes.
Treatments. Treatments. Treatments.
Okay, so time's up. Okay, so please submit to me the answers. Okay. Again. Julian. Okay. Syafika, namakan dia quiz 11 You all semua sepatutnya. Sorry, quiz 11 lah. Quiz quiz 2. Ajar.
Soalan yang latest ni ke Prof? Quiz 2.
Yang latest ni quiz 2 kan, saya ada tulis atas tu. Ya, quiz 2. So next time follow quiz tu sebab ada banyak quiz, nanti kan saya confuse, you punya markah tertinggal nanti. Okay, so Hajar dah, Julien dah, Kamarina, Hanisa mana?
Saya dah hantar Prof dekat WhatsApp. Ada dapat tak?
Okay. Ini Kamarina. Okay. Ini Anissa. Okay. Syafika dah hantar Syafika.
Apa? Saya resubmit yang baru tu. Saya tukar dia punya nama. Saya tukar nama quiz.
Okay. Got it. Okay. Farhan sudah. Okay. So semua dah hantar. Okay. Good. Okay. Kita ada 7 minit untuk discussion. Okay. So okay. So ini adalah dia punya Farhan punya apa ni? List of treatments. Okay, so how many factors? So ada 2 factors. Okay, 2 factors. Okay, so how many levels? Okay, so untuk PTFE, faktor pertama, how many levels? So you can tengok kat sini. Okay, so remember kalau untuk CCRD dia bukan macam factorial design yang mana semuanya dia teratur. So CCRD dia kurang teratur sebab dia nak dapatkan apa tu rotational punya design tu kan. Okay, so dia tidak akan begitu teratur. Okay, so kalau how many levels? Okay, so you kena tengok kat sini dia ada 1, 2, 3, 4. Okay, so kat sini dah ada juga kan 20. So tak kira lah, 12 dah ada, 4 dah ada, 23, 5. So 12 dah ada, dan so 12. So dia ada 5 levels for PTFE. Okay. Okay, and then untuk exposure time, okay, so there are 2 factors, PTFE concentration dan exposure time. Sorry, untuk exposure time, okay, dia ada 18, 1, 2, 3, 18 dah ada, 6 dah ada, 18, 36 So 1, 2, 3, dah ada, dah ada, dah ada, dah ada, dah ada, 4, okay, 5. So dia ada 5 level juga, okay. Okay, tetapi combination dia bukan straightforward macam tadi macam factorial. Okay, so meaning that okay, dia punya treatment adalah is a combination of the levels. Cuma dalam kes ini dia bukan 5 kali 5. Okay, disebabkan dia tidak cover semua. Okay, sebagai contoh 12, 18 kan. Okay, so kalau you tengok 12, 18 lagi di sini. Okay, so kalau 12, 18, 12, 18, 12, 1, 12, 18, 12, 35. Dia tidak ada 12, 30. Walaupun 30 ada di sini. Okay, so dia berbeza dengan factorial design. Okay, so dia tidak ada 12, 6 contohnya. Okay, so dia tidak cover semua levels tu. Okay, so ianya berbeza. Okay, so dengan itu, dia punya treatment ada berapa? Dia ada 13 tolak. Sebab yang ni adalah replication kan, yang asterisk ni, yang Farhan kata ni, center point, replication. So dia ada 5 replications of the center point. Okay, so the number of treatments adalah 13 minus 4. That will be 9. So 9 treatments, including the center point. Okay, boleh So, because of the center point, okay, total you have 13 experiments, 13 runs. Okay, but this consists of 5 center points. Okay, so minus the 4, so the number of treatments will be 13 minus 4, meaning 9 treatments. Okay. Okay. Responses, okay, responses at all the things that, all the aspects that were being measured. Okay, mana tadi? Okay, so SEM, FTIR, SPS dan sebagainya, etc. etc. Okay, so come back to this one. Okay, so okay, how many treatments are there in the study? So we've calculated it just now. You have 13 minus 4 equals to 9 treatments, and then list the treatments in the study. So you have to list everything, okay? But only once for the center points, okay? Okay, over here also you can see the the difference between CCRD and also factorial design. Okay, so if for example, sorry. So if for example, if you want to do a factorial design based on these 5 levels for PTFE and also 5 levels for exposure time. Okay, then you will have a 5 times 5 equals to 25. So you will be having 25 treatments. Okay, times 3 for replication. Then you will have 75. Okay, so you will have 75 experiments. Okay, let me just jot it down here. Okay, so based on what we have discussed just now, okay, so we have for PTFE, okay, 5 levels. Okay, and then for the second one, what is it? Second factor, exposure time. We have another 5 levels. Okay, so if you are using a factorial design, then the number of experiment, so it will be 5 times equals to 25 treatments. Okay, so if you have 3 replications, so 25 times 3 equals to 75 samples. Okay, so that is what had to be done. But if, like Farhan is going to use a CCRD, so okay, the number of experiment will only be 13. Okay, inclusive of replication. Okay, so you can see how from 75 samples is being reduced to only 13. Okay, it's being reduced to only 13 over here, and this is the only experiment that you need to do, meaning that you don't need to replicate anymore because the replication has been done only for the center points 5 times. Okay, so by using CCRD, we are able to reduce the number of experimental runs that is needed. Okay, so that is the strength. Okay, the weakness is that, as we have discussed in class, is that it's, if you want to look at the mechanisms, okay, the cost-effect relationship, then it is more difficult because, as I've showed to you just now, for example, like you have 12, 18, but you do not have 12, 6, for example. Okay, so it's going to be more difficult. So that is why usually CCRD is being used for optimization to develop the response surface. Okay. Okay, any other questions? Okay, so if there are no questions, so we'll stop here today, and for next week, okay, we'll have another 4. Okay, 1, 2, 3, 4. We'll try to finish 4 presenters. Okay, for presenters for next week, and then the week after that will be your mid-semester exam. Okay. Okay. So, any other questions? If there are none, so we'll stop here for today. Okay. Thank you.
Thank you, Prof.
Thank you, Prof.
Thank you, Prof.
Thank you, Prof.
Thank you.
Thank you, Prof.